Good morning. Today we're going to look at section 5.1, day 2. We're going to look at graphing polynomial functions and describing their end behavior. So by end behavior, we're referring to the directions of the graph to the far left and to the far right. So not really what's happening inside in the middle of the graph towards the origin, but what happens as we move far to the left or right for the x-axis. So determining end behavior, the first thing you want to do is look at the degree of the polynomial. Even degrees, like x squareds, x to the fourths, will look like parabolas. So both arrows pointing up or both arrows pointing down. Okay? Odd degrees are going to act more like a line. So they're going to be going in opposite directions, one pointing up and one pointing down. How we determine what they're going to look like is based on their degree and then the leading coefficient. So we have to look at that very first number and determine if it's positive or negative. For even degrees, it's going to look like a parabola. So both will point up if the leading coefficient is positive, and both will point down if the leading coefficient is negative. So we refer to that as up, up, up on the left and up on the right when it's positive, or both down. So down on the left and, down on the left and down on the right, if the leading coefficient is negative. If it's an odd degree, we said it looks like a line. And if the leading coefficient is positive, think of a positive slope. So it's going to start down and move up, like we have in this picture here. Or if the slope is negative, meaning that leading coefficient is negative, it's going to start up and then go down like we have there. So we want to focus on that very first term when it's in standard form. We look at the power to determine the degree, and then we look at whether it's positive or negative. So again, even, it's going to look similar to a parabola. Both arrows will be going in the same direction. Odd, it's going to look more like a line. Arrows going in opposite directions. So let's try a couple. For this first one, I've given you the shape of the graph, but you wouldn't even have to have that. If we focus just on this leading term, it is in standard form, so we're taking that first term. It has an even degree, and the leading coefficient is positive. So both arrows are pointing up, so we would refer to that as up, up. For this next one, again, focusing on the first term when it's in standard form. Our degree is even, and our leading coefficient is negative. So we are looking at down, down. So down on the left and down on the right. Okay, for our next one, standard form again, looking at the first term. This time we have an odd degree. So think odd, opposite directions. Leading coefficient is negative. So think of a negative sloping line. It's going to look like that. So we would say it is up on the left and it is down on the right. Now, as you go on in math classes, as you continue on next year, you will see other ways of describing end behavior. Sometimes they describe it as a limit. So, for example, for this last one, we could say as x approaches negative infinity, as we move far to the left on the x-axis, so going this way towards negative infinity, my y values are going up. So y is going towards positive infinity on the left. But as x approaches positive infinity, so as we're moving farther to the right, we're going towards positive infinity. Now my graph is pointing down, so y, or f of x, is approaching negative infinity. Just another way of stating end behavior that you may see as you continue on in classes. All right, so let's try some that just have an equation given without our picture to support our answer. So the first thing we want to do is make sure our equation is in standard form, and it is. So we look at our first term. Our degree is odd, and our leading coefficient is positive. So when the degree is odd, think opposite directions. Positive, think positive sloping line. So we would say on the left side it is pointing down, and on the right side it is pointing up. All right. For the next one, it is in standard form. This is my highest powered term. My degree here is even, a 6, and the leading coefficient is negative. So even degrees, we think of parabolas, so either both up or both down. And since our leading coefficient is negative, this would be down, down. So down on the left and down on the right. All right, go ahead and pause the video and try these next two. All right, let's check what you did. First term in standard form is this negative 4x to the 5th. We have an odd degree, so we think opposite directions, and we have a negative leading coefficient. So if the leading coefficient is negative, think negative slope. It's pointing down like that. So on the left side of my graph, it is pointing up. On the right side, it is pointing down. For the next one, first term is 3x to the 4th. We have an even degree, and we have a positive leading coefficient. So this should look like an right side up parabola. So you should have up and up for both left and right. All right, so putting it all together, we have an equation here, y equals 3x minus 2x to the 4th plus 2x minus 1. First thing we need to do is put it in standard form. Our very first term is this negative 2x to the 4th, so I'm going to put that first. It is my highest powered term. Then notice I have two separate terms that are both x. We want to combine those into one. So we have a 3x plus a 2x. We now have a 5x. And then we have the little constant negative 1 at the end. So in standard form, that would read y equals negative 2x to the 4th plus 5x minus 1. To name it by degree, we are looking at the 4. That is our degree. A degree of 4 is called a quartic. And to name by the number of terms, we count pieces. So 1 term, 2 terms, 3 terms. 3 terms would be a trinomial. So that is a quartic trinomial. Now for the end behavior, we have an even degree, and our leading coefficient is negative. So even degree means parabola shape for end behavior. It can do some different things in the middle of the graph where it wouldn't look like a parabola, but your arrows are either both up or both down. Since our leading coefficient is negative, they would be both down. So we would say down on the left and down on the right. So as you go through homework today, you'll notice that we do a lot of reviewing from the first day of this chapter, where we talk about classifying polynomials. So just a quick review before we look at this last little piece. We can classify by degree or by number of terms. Number of terms is we have fewer options. 1 term is called a monomial, mono meaning 1. 2 terms is a binomial, bi meaning 2. 3 terms is a trinomial, tri meaning 3. And after that, we just say a polynomial with whatever number of terms. So 4 or 5, 6 terms. For degree, we have more options here. Degree 0 is called a constant. That means there's no variable. It's just a plain number. Degree 1 is linear. It's going to look like a line. Degree 2 is our quadratics, all of our parabolas. Degree 3 is a cubic. Degree 4 is quartic, like our example above. And degree 5 is quintic. And I doubt you'll see anything higher than that in this class. All right, so last little piece is just a lead-in for tomorrow. We will be talking about turning points. A polynomial can have as many turning points as one less than its degree. So what we mean by that, if we have a line that is degree 1, okay, linear, and we have no terms. No turns. Degree 1, we had 0 turns. Degree 2 is our quadratics. Those are the parabola-shaped ones. Degree 2 has 1 turn right at that vertex. A cubic, which is our next 2 pictures, degree 3 is going to have the maximum number of turns it could have would be 2. If it's degree 3, we have to take 1 off, maximum number it can have. So in our first picture, it really makes no turns. It's just a very smooth curve. A turn is going to be changing complete directions. This is still continuing up. It's just making a little twist. The second picture here, you'll see 2 specific turns. One right here, and then another one right here. Okay, we're completely changing directions. So it can have 1 less than the degree. So this was degree 3. We take 1 off. The maximum number of turns it can have is 2. However, it can have less than that, and it alternates. So a degree 3 could have 2 or 0 possible turns. So a quartic, degree 4, the maximum number of turns it could have would be 3. We have a couple pictures here. So degree 4, 4 minus 1 gets us 3. That's the maximum number of turns. This first picture shows us that. Okay, 3 turns. Or go down, skip 1 number. Our next option would be 1 turn, and that's what this picture is showing. So it can have 3 or 1. So what we mean by that is if we had, say, degree 7, the maximum number of turns would be 6. But then it can also have 4 or 2 or 0 turns. All right? Again, it's going in alternating numbers. All right. So we will stop there for today, and tomorrow we'll look at section 5.2.